Good evening, students. Today, sir will be discussing very critical quiz questions today. Conceptual quizzes Galore 1. Like this series of quiz questions I'll be discussing. Today, 4 varieties of quizzes are there. Paragraph, single cut option, numerical, multi-cut option, like this, and which we have the questions are based on my previous lectures, and these are my credentials. I don't have to say it again and again. So first question on projectile motion is a paragraph based question. A particle is projected at angle 30 degrees with the horizontal with a speed u and hits a point light source. There is a light source with a point light source on the horizontal surface. So that must be at the distance range from the projectile, from the projection point, because it is projected at angle 30 degrees and it is falling and striking on the horizontal ground, hitting the point light source. The distance between the point of projection and the light source is R, capital R. You must be knowing that is nothing but a range. A vertical screen is fixed passing through the point of projection where the shadow of the projectile falls, because the point before being struck by the projectile is a light source. So now answer the following questions. So this is the passage based on video lecture VDL 4, shadow projectile, uploaded on 31st July, 10 months ago. Okay. So this paragraph, so question number 1 of the paragraph, until the light source is knocked out, will knock out the light source after it strikes. So what are choose the correct options. A, the speed of the shadow of the particle on the screen remains constant. B, the speed of the shadow of the particle on the screen increases continuously. C, the speed of the shadow of the particle on the screen decreases continuously. D, the speed of the shadow of the particle on the screen first increases, then decreases. So A, B, C, D, 4 options I have given. So which is the correct one? This is the question number 1 on this paragraph. The question number 2 is the total distance traveled by the shadow out of the 4 options are root 3, are by root 3, root 3 are by 2. Which is the correct option? 3. The height of the particle or that projectile particle from the horizontal surface when the distance of the shadow from the point of projection equals the maximum height of the particle from the horizontal surface. Okay, the location of the shadow from the point of projection is equal to capital H. Capital H is the maximum height of the particle from horizontal surface. Okay, so when the shadow is a distance capital H from the point of projection, what is the distance, what is the height of the particle from the horizontal surface? That is, what is the y value of the particle? Then I have given 4 options: r by 8, root 3 r by 8, r by 16, r root 3 by 16. Answers are, for 1, it is A. The speed of the shadow of the particle on the screen remains constant. For question number 2, it is C. R by root 3. Total distance traveled by this shadow just before the point source of light is knocked out. Question number 3, that's what I told. The distance of the shadow from the projection point when the height of the particle, when the distance of the shadow from the projection point is equal to the capital H, means the maximum height of the particle from the horizontal surface, that time what is the height of the particle from the horizontal surface. तो solution देखते हैं. ये है projectile projected from point O with an angle 30 degree with the horizontal with a speed u, and strikes this point source of light, which is a distance r from the point of projection pull, and this is the screen, vertical screen. I have shown it by the red arrow mark, and as the particle moves, the light coming in straight line will make the shadow fall on the screen. These are the different points. These black dots are different points of the particle. So if I'm extending with dotted red line, that is the and which it intersects are points with the shadow position on the screen. This shadow position. This is shadow position. Here the shadow moving with the velocity VSH. Here also moving with VSH. Let us see the VSH. And this is the point P at some x comma y. This is the x-axis. Let me say this is my x-axis. Horizontal is x-axis and vertical is y-axis. Right. So x comma y is the arbitrary position of the particle at some time. Okay. So OD is x. OD is x and PD is y. ODX, PDY. X comma y is the position of the particle. So y is equal to x tan theta minus gx square by 2u square cos square theta. Huh? Looking like cos 2 theta. मैं इसको थोड़ा सा चेंज करता हूँ. Cos square theta. Okay. This is the y is equal to x tan theta minus gx square by 2u square cos square theta. As you all know, this equation of the path of the projectile. I am neglecting the air resistance. So x tan theta, if I take common, there is 1 minus gx by 2u square cos square theta. Tan theta is sin theta cos theta. I bring g down, this becomes range. So x tan theta 1 minus x by r, or x into r minus x tan theta by r. This is the y. Okay, where r is the range of the projectile particle. So y is equal to how much we got? X into r minus x tan theta divided by r. This is known as range form equation. Very useful equation. So there are two triangles now, SOL and PDL. The two triangles, they are similar triangles, 90 degree, 90 degree. This common theta. So this theta, this angle will be this angle. This common angle between the two triangles PDL and SOL have a common angle, and they have a 90 degree angle each of them. Then the third angle will be equal. The three angles same, they are similar triangles from basics of geometry. Okay, so corresponding side ratios will be equal. So for the corresponding sides, YSH, that is SO by PD, is equal to OL by DL. SO is YSH. PD is Y of the projectile particle, simply Y. OL is range. ODX means DL is R minus X. So YSH by Y is R by R minus X. Simple, the similar triangle case. So YSH by Y is R by R minus X. So what is YSH? RY by R minus X. That is this ry by r minus x, ry by r minus x is x tan theta from range form equation. So ysh is x tan theta. So d by dt of ysh is tan theta is a constant because angular projection is fixed. So dx by dt tan theta. So this is dx by dt is vx tan theta. What vx is always constant, so that is ux tan theta. But ux tan theta is uy. So u sin theta. So vsh dy by dt is vsh. So vsh is the equal to what? Component of projection velocity along vertical, that is u sin theta. U is a constant, theta is projection angle constant, so vsh must be constant. Okay, it is neither increasing or decreasing. So answer is of question number 1 is what we wrote. Answer to that is 1a, that is constant. The speed of the shadow, the particle speed remains constant, that is correct option A. Now the total distance traveled by the shadow. That is very simple, since we know the speed of the shadow is constant, and just to find the time. Time is the time of flight. So multiply that. That's it. Okay. So time of travel of the shadow is time of flight of the particle 2u sin theta by g. So distance of the shadow from the origin at the origin from the point of projection at t is equal to 2u sin theta by g is how much? U sin theta into time is 2u sin theta by g. At t is equal to this. This is the distance. So that is how much? U square by g 2 sin square theta, that is u square by g 2 sin theta cos theta divided by cos tan theta. Sin square theta means sin theta cos theta into tan theta. So this is the range into tan theta is tan 30 degree r by root 3. That's it. This is answer to question number 2. R by root 3, there is option. Question number 2 में कोई option है R by root 3? Yes, C option. So C option is correct. 2C. Now question number 3. Question number 3 में क्या देखेंगे? When he is saying when ysh is the maximum height, that is u square sin square theta by 2g. So find the y of the particle. We use range form equation. Ysh by y is r by r minus x. Just above I wrote that. So h by y is r by r minus x. Ysh is capital H. So capital H is the maximum height of the projectile from the ground. So y is equal to r minus x by r into h. So r minus x by r into u square sin square theta by 2g. So that is r minus x by r from range form equation. R minus x is x tan theta by y. है ना? Okay. So r minus x by r. So from the range form equation, what is r minus x by r? Y is equal to r minus x by r h. That is r minus x by r u square sin square theta by 2g. So r minus x by r is equal to, you can see, is equal to y by x tan theta, r minus x by r. Yes or no? Y by x tan theta into u square sin square theta by 2g. So y cancel, x is u square by 2g sin theta cos theta. So that is r by 4. This is the x coordinate of the particle. Then what is the y coordinate of the particle? X range from equation, x into r minus x tan theta by r, r by 4. R minus r by 4 is 3r by 4, tan theta 1 by root 3 r. So that is root 3 by 16 r. So answer to question 3 is root 3 by 16 into R. Very simple question. I just wanted to use the range from equation so that will be familiar. Okay. So what is option 3? R root 3 by 16. So option D. So option A, option question 1A, question 2C, question 3D. So one question, paragraph question is over. Let's go to the next page. है ना? नेक्स्ट पेज में क्या करेंगे? अदर क्वेश्चन देखेंगे. और सिंपल क्वेश्चन पूछा मैंने नेक्स्ट पेज में, बट इंपॉर्टेंट. ये इक्विवेलेंट सेल के ऊपर आई हैव डिस्कस दिस in my video lecture VDL 148, balanced Wheatstone bridge connection of the cells, uploaded yesterday only, the 15th June 26. Okay. Okay. What is the question? The combination of 5 cells, E1, E2, E3, E4, their respective interactions R1, R2, R3, R4. The numerical values also I have given, and this is the cell in the bridge connection. So at what value of R load is the load hai, that bunch is connected across a load, supplying current to the load, and our power output to take through the load. So at what value of R load is the power output through the load is maximum? Say numerical question, answer time. So in what? In ohms is asking question, that is 2 ohms. At what is the maximum power output through the load? In watts, so that is 4.5. Okay, let us see this. As I told earlier in this our discussion, in the VDL 148 is a Wheatstone bridge arrangement of cells. R1 is 1 ohm, R2 2 ohm, R3 2 ohm, R4 4 ohm. See this? This is 1 ohm, 2 ohm, 2 ohm, 4 ohm. So the R1 by R2 1 by 2, R3 by R4 also 1 by 2. So that is they are in balanced. This is a balanced Wheatstone bridge of the cells, as I explained in my video lecture. Understood this? So that means to calculate the cell equivalent, I can remove this bridge cell, and if I remove that, then these two cells will be series. These two cells will be series, and both the branches in parallel. Step by step I do. It is a balanced Wheatstone bridge. Remove E0, R0, that bridge cell, and calculate EQ and REQ, equivalent, R equivalent. I have to express this as a single equivalent cell and equivalent internal resistance, this bunch connected across this load. So that same load current will be flowing as in this case. So I remove the E0, R0, that bridge cell. So what remains? 10 volt in this manner, 4 volt in this manner. Just see this. This is this way connected. This is polarity is reversed. Here this is connected this way, and this is the reverse polarity to this cell. So finally, what will be the connection? This like this. So what is this? This is 4. This is 10. So resultant will be 6, and interrelation will be added. 2 plus 1, 3, 6, 3. And similarly here, this is 9, this is minus. So 6 again this side, to this side polarity plus. So 6, and what is the equivalent internal resistance? R4 plus 2, 6. So 6 volt upper branch, 6 volt battery, EMF, and internal resistance 3 ohm. Lower branch, lower parallel branch, 6 volt EMF and 6 ohm internal resistance. So what is the equivalent of these two parallel, this parallel combination? This is E equivalent, R equivalent. How to find that? Basic normal parallel formula we use. E equivalent is E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So 6 by 3 plus 6 by 6 divided by 1 by 3 plus 1 by 6. So this becomes 3, numerator 3, denominator is half. So 6 volt. 6 volt is E equivalent. Yes or no? So 6 volt is E equivalent. What is R equivalent? 1 by R1 plus 1 by R2, that is 1 by 3 plus 1 by 6, that is 1 by 2, that is 2 ohms. Very simple. So this is what I wrote. 6 volt, E equivalent, R equivalent is 2 ohms. And the load is capital R variable. So at what value of load resistance maximum power when R is equal to 2 ohm? Answer is R load is R equivalent 2 ohm, maximum power output is obtained through the load. Question number 1 answer. Then P max is E equivalent square by 4 R equivalent, that is 6 square by 4 into 2. So that is 4.5 ohm. So that is answer to question number 2. Okay. So this numerical answer is there. So this I am discussing why? Because you don't see them in normal books. So but it is very simple. If they ask, you can note time, you can answer. Because cell combinations they are in your syllabus. Then question number 3, I am discussing river swimmer problem. Is a single cut option question. This is a very simple question, you must be knowing, but this river swimmer, you must have done many, all of you must have done many, but I am asking some twist in the question. This is also from my video lecture, VDL 58, relative velocity 2, that is work done in swimming, rowing, etc. Uploaded on 26 January 2026. Okay, a river of width 1 kilometer, the river width 1 kilometer, flows west to east with a uniform speed of 1.5 kilometer per hour, typical value. A man having a swimming speed of 2.5 kilometer per hour crosses the river. I don't have to say with respect to what. Swimming speed means swimming on the river with respect to river 1. That speed is how in any direction swimming speed is unchanged. So 2.5 kilometer per hour is the man has the capability of swimming on the river. So that is 2.5 kilometer per hour is swimming speed of the man. Crosses the river along the shortest possible path. Okay, the swimmer has a mass of 60 kg. A mass का क्यों दिया देखते हैं. The drag force applied by the river water on the man while swimming is typically 0.1% of his body weight. That's why the mass I gave. What is the energy spent by the swimmer in crossing the river in joules? G is equal to 10 meter per second square. 4 ऑप्शन मैंने दिया joules में. 450, 600, 750, 1000. Which one is correct? Answer C is the correct. 750. Let us see. Then refer to the video lecture VDL 58 as I told you, relative velocity 2, work done in swimming, rowing, etc. That is the name of the video lecture. Uploaded on 26 January 2026. Solution देखते हैं. D is 1 kilometer, the width of the river. Friction force is 0.1% of the weight of the swimmer. So 0.1 by 100 into 60 into G is 10. That is 0.6 Newton. This is 0.6 Newton. 0.6 Newton. Okay. Fine. We know that the work done per second by the sliding friction force is -1 magnitude of friction force into relative speed. We know this from the work energy chapter, and this video lecture I have discussed in detail. So that is how much? -1. Friction force is 0.6 into VMW. Assume that the friction force remains constant for the simplicity's sake. VMW is the man with respect to water, that is the relative. So minus 0.6 into VMW. VMW how much? 2.5 kilometer per hour. That is 1000 by 3600 meter per second. So that is minus 0.6 into 25 by 36. That is minus 5 by 12 watt. This is work done per second by the friction force. So if it is negative work done per second by the friction force, but man has to maintain its velocity, then he has to compensate for this negative work done by the friction by doing this much amount of positive work by his muscle forces. So power developed by the muscle forces of the swimmer is plus 5 by 12 watt. So that he maintains his speed relative to water throughout. So what is VMG? This is VMW. This is the river width. His body has to move from A to B, shortest path. So he has to aim like this, and VWG is the velocity of the river water, and his velocity of the man's body with respect to ground will be along A to B. That is VMG. So this is VMW square minus VWG square, root over is VMG. So this is 2.5 kilometer per hour. That is 2.5 square minus 1.5 square, root over is 2 kilometer per hour. So VMG how much? 2 kilometer per hour. So how long it will take to go from 1 to B, A to B? D divided by VMG. That is 1 kilometer divided by 2 kilometer per hour, 0.5 hour, half an hour it will take. So it will cross the river in straight half an hour. So how much energy spent by the person in crossing the river? He is spending, what is the power developed muscle force? 5 by 12 watt. And time taken is how much? Half an hour. So that is total energy spent will be by the person in crossing the river will be power into time taken. 5 by 12 into 0.5 into 3600. So this is 1800. 5 by 12 into 1800 is 750 joules. Remember, this is what is the crucial point in this? Work done by the sliding friction force is -1 F magnitude into relative speed. This is the crucial point. After that, everything is very simple. Am I clear? आप लोग फिर देखते रहेंगे, ये पूरा आज का जो लेक्चर है पूरा देख लो एक बार. आपको कभी ये सब क्वेश्चन आपको शायद बुक में नहीं होगा, तो आप इधर ही देखो. और एक क्वेश्चन है शिफ्टिंग ऑफ सेंटर ऑफ मास. अच्छा, एंड दिस इज मल्टी करेक्ट चॉइस है. उसके लिए आप, दिस इज ऑल्सो बेस्ड ऑन माई वीडियो लेक्चर BDL 5 shifting of center of mass, uploaded on 2nd August last year 2025. More than 10 months हो गया, आप देख लो इसको. ठीक है, तो क्वेश्चन क्या है? A plank of mass in lies on a rough horizontal surface. हमेशा आप लोग अभी सुने होंगे कि अभी तक किए होंगे स्मूथ हॉरिजॉन्टल सरफेस. Okay. A person of mass small n walks from left end of the plank to right end of the plank. The surface exerts a friction force, the surface of friction force, but that friction force is proportional to speed of the plank. F is equal to minus kV, where V is the velocity of the plank with respect to surface. K is a positive constant. Minus sign once I write, K is a positive constant. So, and V is what? Is the velocity of the plank with respect to surface. Remember this. Don't say velocity of the plank with respect to anything. There is velocity of the plank with respect to surface, ground. The man reaches the right end of the plank. There is friction force between man's feet and the plank. Otherwise, he cannot walk. Okay, fine, but it is understood. So man reaches the right end of the plank and stops. We don't know what is the behavior of the friction force between man's feet and the Planck surface. That we don't know. But we know the friction between Planck and the ground surface, the rough horizontal surface, obeys F is equal to minus K into V of the Planck. Here. So which of the following options is or are correct? Maybe one or more than one may be correct option. A. Final displacement magnitude of the Planck, displacement magnitude is greater than 0 but less than ml by m plus m. It will be equal to small ml by m plus m if there is no friction. So it is less than that but greater than 0. That's what my option. Option B says final displacement magnitude of the Planck is 0. Option B. Option C says the final displacement magnitude of the man, that is, when I don't say with respect to what, we say respect to ground, that is greater than ml by m plus m. It will be equal to ml, capital ml by capital M plus m if there is no friction between the Planck and the ground. But since friction is there, it will be greater than capital ml by capital plus small m, but less than L. That's what I'm saying in option C. And option D is final displacement magnitude of the man is equal to L only with respect to ground. And my answer is option B and D. The final displacement of the Planck will be 0 and final displacement magnitude of the man is L. भाई ये कैसा है, ये थोड़ा सा ठीक नहीं लग रहा ना, देखते initial momentum the Planck and the man system, when just before man starts working, how much? P initial is null, when 0 vector. When man stops at the right end, the friction force between the Planck and the surface, ground surface, brings the Planck to also rest after some time, assume, allow that time. So final momentum of the system will be how much? Man has stopped with respect to Planck, and finally Planck also stops with respect to ground due to friction. So final momentum system becomes Pf bar is equal to null, that is 0. Pf bar is 0, Pf in is 0. So what is the delta P in the system? When motion is over, that is 0 also. This minus this, 0 minus 0, 0. So what is the external force in this on the system? Only friction between ground and the Planck, that is minus kV bar. So what is J external then? Impulse, external impulse, that is F bar dot dt integration from 0 to delta t. Delta t is the duration of the motion. Minus k V bar dot dt. V bar is what? Velocity of the Planck. Dot V bar dt will be dx bar. So minus k outside, v dt is dx bar, from 0 to delta t, it will be delta x Planck. But we know that J external impulse is change in momentum of the system, which is 0, already I have proven. So J external 0 means minus k delta x bar Planck is a 0 vector. So delta k is not 0. K is not 0. It is a, I told k is a positive constant. If k is not 0, then delta x is definitely 0. The delta x Planck is definitely 0. So, surprising result, at the end of the motion, we find there is no displacement magnitude of the Planck. He might have started moving, but at the end of the whole thing, at the end of the day we call, at the end of the motion, Planck is as is where is position. Therefore, the displacement of the man with respect to the Planck will be the displacement of the man with respect to ground, because with respect to ground, Planck has not moved at all at the end. So, what are the options? Delta x Planck is 0, option B. And since with respect to the Planck, the man has moved to L, and Planck has not moved at all at the end of it. So, the with respect to ground also, the displacement man will be equal to with respect to ground will be equal to what? L. Okay. Therefore, the displacement of the man with respect to the plant is equal to displacement of the man with respect to ground is L, because we know that man has worked from left hand to right hand with respect to the plant, that is L displacement, and plant has not moved with respect to ground. So with respect to ground also the displacement magnitude of the man is L only. So option D. Let us see the options once more. Final displacement of the plant is 0, option B correct. Here wrong. So final displacement magnitude of the man is L, that is also correct. So C wrong. So B and D are correct, and this is the B and D are. I put है ना. So note इस और एक बात जो चीज मार्क करना है क्वेश्चन में, और एक का दो important points मैंने लिख दिया. So J external is 0, FDT 0 to delta T, that is F average into delta T is 0. So delta T not 0. So F average during the motion is also 0. Average friction force during the whole motion exerted by the ground on the plant is also 0. So displacement of the center of mass of the system. The plant has not moved. Only the man has moved a distance L with respect to ground. Planck has not moved at all with respect to ground. So what is the displacement center of mass? Small m L divided by capital M plus small m to the right. Because man has displaced L to the right with respect to ground. Planck has not displaced at all. So what is the displacement center of mass with respect to ground? Small m into L divided by m plus n to the right. ये दो चीज आपको ध्यान रखना है. अगर ये भी ऑप्शन में कहीं आ जाएगा तो इसे आपको कोई दिक्कत नहीं होगी सॉल्व करने. ठीक है, am I clear? बताओ, कुछ डिफिकल्ट है तो बताओ. ये जो 4 क्वेश्चन में क्विज क्वेश्चन दिया, because I have decided that I have to ask some questions on my previous videos, so that you will be seeing. You are not seeing my videos. So serious people who are really seriously preparing for IITs, NEET, go through my videos. The help will be immense. You will realize that as time progresses. Okay, I have been teaching for a long time for people like you, produced many All India ranks starting from 1. So take my videos very seriously and note down them also in your notebooks so that you won't forget. So that, because many things you will definitely not find in the books. So, okay, all the best to you. Have a nice day. We'll meet again very soon with some extremely conceptual discussion. Thank you all. Have a good day.